Okay, good evening. So for our mechanical dissection tonight, we're going to be doing an X-Acto brand School Pro pencil sharpener. And pretty basic design. These things have been around for quite some time in one form or another. And it's electrically driven. As we can see, we've got a cord here, an ABS plastic shell, which we'll dive into a little bit later. You can, of course, adjust pencil sizes. Interestingly, right here, this is actually a triangular hole, so similar for the pencils that I think Stedler uses. A couple other companies use the triangular pencils. So all sorts of different sizes. Okay, they have the one marked for standard number 2. We're going to tear this thing apart. I wound up with a whole box of these that a teacher gave me because they fail, and his goal was to have students maybe pop them apart and do some investigation as to why they work. We're going to take that role tonight, so let's dive in. So first things first, a little bit of investigation. We look at it. It's dirty, pretty simple, has suction cups on the base. It's got this little drawer in here, all right, that's made out of some type of what looks like probably Lexan, so it would be acrylic, all right, and that has more than likely been injection molded. We can tell that by these little lines right here. And you will note that it has this little nub that sticks out. That's going to come into play a little bit later. It also has a small catch basin in the bottom, all right, that interfaces right here. That's what holds it in place. I'm going to be honest, it's kind of funny that these don't do that great a job of catching the shavings. You'll notice that there's all sorts of stuff behind here. Wait till we get inside. A little bit of a failure as far as product design goes. But, all right, it works, it's strong, it's clear, it looks good. So we're going to set the drawer aside. We don't need that. Now, when you look at how this thing is assembled, we will note, okay, there are 2 nuts in here, so clearly there's screws that go in the back, and if you look up inside, you'll see the mechanism, all right, that has the cutter head in it. We'll deal with that in a little bit. I will say that the fit inside of the casing is awful. It's not particularly close. It does go up inside, but it's a pretty sloppy fit. What we are going to have to do is flip this thing over, up on end. There are 2 screws right here, and 1 back here, and we'll pop that off first, and that's how we're going to get this outer cover off. And then we'll worry about taking some of the other pieces off. So let's go ahead and do that. We're going to use our number 2 Phillips screwdriver. These are high-pitch threads, so, or I guess supposedly low-pitch we should say. You'll notice that they have a very aggressive thread that's spread. They almost look like a wood screw. And that's because when you use these, they drive them into the plastic without tapping the plastic. All right, so they don't cut threads into the plastic. The screw does that, so they're self-tapping. It might be a little hard to see, but there is a patent number on the bottom of this. Okay, and X-Acto is apparently owned by Elmer's, according to this, so Elmer's glue, or Elmer's products right here. We do have a patent number for this. It gives you the catalog, or excuse me, the Canada patent number, and a couple other things. It does note ABS here. Okay, so ABS plastic for most of the construction. We have a UL listing, electric pencil sharpener, a couple of other numbers. It does say it's made in China. All right, a model 167X, and it does say 120 volts, 60 hertz, 2 amps. All right, this is going to pop right off, and we have the base. All right, nothing too complicated there. I do want to point out immediately, all right, we're going to set that aside. You'll notice what looks like a transformer in here. This is actually the motor. Look at all the dirt that's inside of that. Okay. I would like to think that the designers would have thought to seal it better, but I guess not. It does have a strain relief on the cord, so we're going to pop that out, just like that. Now, we've got to get a couple more screws out, and those 2 screws are right in here. Again, they're self-tappers, and last time I did this, these were difficult to pop loose, so ideally you'd have a number 1 screwdriver, number 1 Phillips. So far my 0 is working though. And at this point we're free, so we're going to wiggle this out. Obviously this is not plugged in, not a good idea. Alright, we'll knock some of the dirt out of that. And again, pretty basic design. I do think it's interesting when you talk about mold making. The outside of this is a very smooth finish, so it would have been polished. And if you look inside, it might be hard for you to see, you can still see the milling cutter marks inside. So they didn't put that much effort into smoothing out the interior surface. And that's typical of a lot of products because you don't need the mold to be that pretty on the inside. All right, as long as everything is there. We can actually see the sprues. So right down in here, that's likely what those are. Anywhere you see those circular marks, all right, kind of hard to see, I'm sorry, it's not bright enough. Those are where the sprues were, where the injection molder actually put it in. And we can see our towers or our standoffs where the screws went. Little piece on the front has just an E-clip in it, what we call an E-clip or a snap ring. All right, typically an E-clip, and it's just a plastic nub that clicks that in. And I can hear it right inside of here. There's some kind of detent, right? Maybe we will try and pop that. So we're going to use our flat blade screwdriver. And I apologize if you can't see this very well. And we're just going to massage that off. Okay. So we have our E-clip. Set that aside. And there's spring pressure on this, so I'm going to pop this out. You'll see the little housing right in there. We're going to set that aside as well. And inside, typical detent setup, we have our plastic wheel, and you can see these little hemispherical shapes in here. That's what the ball detent sets inside. So this is like a nylon or an ABS as well. All right, set that aside, and then we have a small ball bearing and a spring. And the spring, of course, pushes on the ball pushes against your wheel, and that's what locks it in place. Kind of a standard arrangement, so we'll set those aside. Now we've got the bones of this thing. So we've got two screws again. They've got an aggressive thread, almost like a wood screw thread. So they're self-tapping. I'm still astonished at the amount of dirt that falls out of this thing. It's everywhere. It is all through the gearing in the back. It is, of course, in the cutting mechanism where you'd expect it to be, but it almost seems like this feeds it back through. And it's everywhere. I mean, it's up inside of here. It's in our switches, all over the place. So, definitely taking points off for that one. I think they could do a better job of sealing this from dirt, which ironically is probably what causes the failures in these to begin with. Now, if you think about it, pencils are not made of lead, they're made of graphite, and graphite is an excellent lubricant. So we can surmise that the graphite itself getting through the mechanism is not that big of a deal, particularly with the gears or with the driving, with the cutter head mechanism. I don't think that's a big issue. The wood chips, however, are definitely an issue. Getting wood chips or any kind of debris through any type of moving mechanism is just not a good thing. It never is. Now, in order to take this apart, we've got to do some other disassembling. You'll notice our wires right here are routed in along here. They do have a nice little slot for them to feed through in, and that's okay. What we can do to disassemble this is, I think we're going to start back here at the motor. All right. And they've got some zip ties on it, wire caps again, standard arrangement. We're going to take our number 2 Phillips, and we're going to start by removing these 2 screws. I'm going to wiggle this bearing cap off. So this black piece right here is the rear end of the motor. We're going to wiggle a little bit, it'll come out, along with our 2 screws. Okay, so we'll disassemble those. So the screws look just like this. I do want to point out the bearing cap is nothing more than some type of plastic. It almost looks like, I would say it's probably a nylon, because that's pretty typical of using things for bearings, because they have some lubricant properties. It's interesting though that there's no type of hard bearing surface in here, so a better motor would have something like a bronze or a sintered bushing in there. This one doesn't have it, so cheap part, but I guess it works. Lay that off to the side. The next thing that we can do is we can take the rotor out. So this should just pluck right out of here. We have to turn it slightly because on the end is a nylon spur gear. And it does have a little bit of a helical cut to it, okay, as does the other gear. All right, so this would be referred to as our pinion. So this spins at a high rate of speed. Okay, so we're going for torque in this instance. All right, we know that because the motor's got the small gear on it. We're not going for speed. And the rotor doesn't look bad. Pot metal construction, nothing too fancy. Very typical of this style motor that you see in appliances. All right, so we've got that. And then, of course, our armature assembly, all right, as well as our washers and nuts, are going to pop right out. And then we'll work at getting this all disassembled. Okay, so we're taking a look at our motor here, and this is what forgive me if I'm wrong, because it's been a while since I looked at these. I believe this is called a shaded pole motor, so it's one of the simplest electric motors that you can have. You have a coil, all right, your armature in here. The shaded pole, what that does is that kind of creates a brake so that the magnetic force of this can get the rotor started spinning. Pretty basic design, but it works. You'd see this a lot in like exhaust fans over your stove, or exhaust fans in the bathroom. Anywhere you need a motor that doesn't have to be sealed and doesn't require a lot of power, but they still generate some force, enough of course, to drive a pencil sharpener. Now we're going to jump in right here. We're going to look at the driving mechanism. So we're going to turn this, and you'll notice that we have a drive gear here. This is nylon, all right, and it is injection molded. I can see the sprue marks there, again, those circles, and it is helical cut. So helical gears are cut in basically a spiral or a helix instead of straight cut. So instead of meshing like this, okay, like what you would see in cartoons when gears mesh together, the teeth are at an angle, and as they come together, they tend to slide past each other a little bit. It creates less noise, less wear, that type of thing. So very, very easy to injection mold something like that. And this is going to be our actual driven gear. Okay, so the armature has, once again, our pinion on here, and that would fit right in there just like that. And then the next thing you know, it's going to turn just like that. So fast spinning motor, slow spinning drive gear, or driven gear, excuse me. All right, we're going to go ahead and we're going to use our number two screwdriver, and we're going to break loose this screw in here. You got to be careful when you're disassembling something like this, because some companies, you don't see it as much anymore, will use a left-hand thread. So if you've been taught the old adage, righty-tighty, lefty-loosey, left hand would be lefty-tighty and righty-loosey. All right, and if it's not marked as such, you can really drive yourself crazy. You'll think the screw's permanently stuck in there because you actually are tightening it instead of loosening it. And this uses a pretty standard type of drive. All right, so it's just slotted. Okay, so they've milled, originally would have milled two flats on the drive mechanism there, and then that's what gives it the positive drive. And there is a boss on the back for spacing. And again, you can see that it has some thrust right there. That's what that ring is from. All right, so if I show you a little bit closer, you'll see those marking. That means that it's been riding on the other plastic. Hopefully they have a little bit of grease in there. There's a tiny bit of lithium grease on this that's left. And again, I don't think they worry so much about this simply because you're going to have graphite that works its way in there, so that's not the worst lubricant ever. What the problem is the pencil shavings, but it's in pretty good condition. There's some gunk in the teeth, but they look okay. So we're going to lay that aside. Now I do want to point out what I believe the culprit is here. This micro switch right here, and this would have been staked in. Okay, so what they do is they have these they're just little cylinders of plastic sticking out of the base, and they take a hot tool and they press down. It's kind of like a plastic rivet, almost, not quite, but sort of. And what that does is that squishes down. Of course, it melts a little bit, and then it locks it on there. It's not serviceable, which is annoying to me. This is probably like a $5 switch, if that. Okay, probably a couple cents in reality. It's a cheap switch. It'd be great if you could pop this out and throw another one in, and you could keep the rest of this going. And I'm guessing that is because when I push against it, I don't feel a very positive clicking. I can kind of feel it, but it's not clicking. If you listen to this switch on the front, which is what actuates it when the pencil goes through, hear that positive click? That's what it should sound like, and it doesn't sound like that. The other pencil sharpener that I ripped apart had the same problem, so I actually think this switch is the weak point in here. All right. Now, I'm not going to disconnect wires at this point, but we just have two power wires, very basic wiring arrangement. You have two lockout switches. So this is lockout number 1. All right, so unless you have the cup, this part, all right, that right there, sticking through the switch, okay, and we'll push it in there just for fun. Okay, that actually doesn't sound bad. It might have dirt in it too. Unless that's in there, it won't turn the motor on. And then of course your actuating switch is right here. When you push your pencil or something in there, that's gonna actuate that and drive the motor. Okay, so not a bad arrangement, just I don't like that cheap switch. Now the next thing that we're gonna do, I'm not gonna disassemble this part of the switch, we don't need to. I am, however, going to take out these two screws right here.